In this last video for Unit 1, we're going to evaluate an expression for changing values of a variable. So the idea here is at the beginning we discussed how a variable can represent a changing value or it can represent a placeholder. And we looked at a few examples of expressions and evaluating or simplifying expressions, but we didn't look at any examples where we evaluated a variable for lots of different values of the variable. So we just want to get this idea or start to visualize this idea of what it means to have an expression evaluated at different values and to see it in context. So let's read the question. Callie places a pot of water on the stove to boil. The original temperature of the water is 20 degrees Celsius, which is 68 degrees Fahrenheit. She measures the temperature of the water periodically and finds that the temperature is increasing at a rate of approximately 8 degrees Celsius every minute. She determines the following verbal equation, and this is a type of equation you're going to find later, but I want you to see how it's built. She says the temperature of the water at whatever time she's measuring it since she starts boiling it in degrees Celsius. Well, it's the original 20 degrees Celsius, plus she's going to add on 8 degrees Celsius for every minute the water is on the stove. Okay. She then defines variables and writes the algebraic expression and formula below. So we're going to use t for the number of minutes. We use t for time. We could have used m for minutes, but lots of times we use t for time, is the number of minutes the water is on the stove. And notice there's two things changing together here, okay? Time is going by, and as time goes by, the temperature of the water changes. So we're going to write another variable. We're going to call it C for degrees Celsius of the water, and that's the temperature of the water in degrees Celsius after t minutes on the stove. So the number of minutes is changing, and as the pot of water is on the stove for longer, the temperature changes. So here's the expression, an algebraic expression. We have 20, so that's the original degrees Celsius, plus 8 degrees times the number of minutes it's been on the stove. And notice that's an expression. It doesn't say it equals anything, but here we have a formula, and capital C represents the degrees Celsius, the temperature of the water after t minutes on the stove. So we could compute the temperature by evaluating this expression for different values of t. So let's fill in this chart. So complete the table below, and there's an example. So after 1 minute, you have the original 20 degrees plus 8 times 1 minute, so it increased by 8 degrees, so a total of 28 degrees. Here's the associated equation, so we take the original expression and say what it is completely simplified. And our interpretation. Remember, t represent the number of minutes on the stove, okay? And our answer is the degrees Celsius at that time. So after 1 minute on the stove, the temperature of the water is 28 degrees Celsius. So let's do the next one together. So let's evaluate this when t is 2. So we have 20 degrees, the original 20. It's 8 degrees per minute on the stove, and we're saying it's 2 minutes on the stove. Okay. Well, let's simplify that. That's 20 plus 16 degrees, so there's a 16 degree increase from the original amount, which is 36. Okay. So this is a string of equivalent expressions that we made that computes or evaluates the temperature of the water on the stove at 2 minutes. Now our equation, we could say that 20 plus 8 times 2 equals 36. And this equation means after 2 minutes on the stove, I'm just going to put the temp is 36 degrees Celsius. So the temperature of the water is 36 degrees Celsius. Let's look at the next one. So t equals 3. So what happens at 3 minutes? We have the original 20 degrees plus it increased 8 degrees per minute for 3 minutes. So that's the original 20 degrees, and it increased by 24 degrees in that 3 minutes, which gives us 44. So our equation is 20 plus 8 times 3 equals 44. So after 3 minutes on the stove, the temp is 44 degrees Celsius. Okay, now I want you to start to see these patterns, okay, because you can use this method, and we will use this method later, for making the equation or expression. So here we were given the expression 20 plus 8t, okay, but I think you could figure out how to find the temperature at all these different values just by evaluating. And notice the pattern. We always start at 20 minutes, and then we add 8 times the number of minutes. So the 20 stays the same, the 8 stays the same, it's changing by 8 per minute, and we're looking how the temperature increases in time. So 1 minute, 2 minutes, 3 minutes. And notice it goes from 28 degrees to 36 to 44. Let's do a couple more. Now at 4 minutes, it's the original 20 plus 8 degrees a minute for 4 minutes. That's 20 degrees plus 32 degrees, which is 52 degrees. Let me put my equal signs. Okay. So our equation is 20 plus 8 times 4 equals 52, which means after 4 minutes, the temperature of the water on the stove is 52 degrees Celsius. Okay, so you may notice I've been shortening the interpretation because we're writing this a lot, but key things that I'm keeping in here, I have the number and the unit of measure, so 4 minutes, and what we're measuring, temperature, there's the temperature and degrees Celsius, unit of measure. Now we're asked to pick our own t. Okay, so I am now instilling in you the power to pick your own variable values. So lots of times you'll want to look for these patterns. I'm going to pick 6 and 8. Okay, and you can pick your own value to evaluate an expression for, and sometimes this is very useful. You don't always have to be given one necessarily. Okay, so even though we weren't specifically told to use the number 6, we can still evaluate this for 6. So at 6, it's 20 degrees plus 8 degrees a minute for 6 minutes, which is 20 degrees plus 48 degrees, which is 68 degrees. Our equation is 20 plus 8 times 6, which equals 68. Notice there's a 16 degree increase from the last one because we went up 2 minutes at 8 degrees per minute, so it went up by 16. So after 6 minutes, the temperature is 68 degrees Celsius. And now let's try 8. Okay, we could have picked anything. I had no idea what I was going to pick. I just chose 4, 6, 8. Seems like a good pattern or a run. Okay, so we have 20 degrees, 8 degrees a minute for 8 minutes, 20 degrees plus 64 degrees, and that equals 84 degrees. So our equation is 20 plus 8 times 8 equals 84. So after 8 minutes, the temperature is 84 degrees Celsius. Okay. Now the next question asks us, is the formula an expression or an equation? So here was our original algebraic expression, and here was the formula where we said that that expression is equal to the temperature in degrees Celsius. So notice we evaluated this expression, and I intentionally had you write this equation because this equation We actually wrote it in the reverse order, but remember we have symmetry, so that's fine. 20 plus 8t equals the degrees Celsius. Okay, so when we were evaluating this expression, we were getting an end result, and we can also consider this the associated equation, okay, that equals the degrees Fahrenheit. Okay, so notice this doesn't have an equal sign, okay, but that can't be your only clue. I could put equals, okay, but this is still an expression because it's not saying two quantities including numbers and variables on both sides. So this is an expression, but this is equal to C, so this is an equation. Okay, and our last question says, water boils at 100 degrees Celsius. Use the pattern in the table and/or guess and check to find the number of minutes it will take the water to come to a boil. Okay, so this is really solving an equation. Okay, so we want to know, okay, when is the temperature in degrees Celsius 100 equal to 20 plus 8t. For what value of t is this true? Okay, and again, we're going to learn how to solve this algebraically using steps, but let's just think about this. Okay, so we saw this pattern. Notice here I had at 8 minutes the temperature was 84 degrees Celsius. So the temperature is going up, it's increasing by 8 degrees every minute. Okay, so we're going to need to add some more 8 degrees to get this to 100. So let's just jot some down. So the next one is 9 minutes. Okay, and I'm going to do something tricky. Instead of filling out this 20 plus 8 times 9, we could absolutely do that, but it would be 8 more degrees than 84. Okay, because remember it's increasing by 8 a minute. So remember when we looked back here, they were going up by 8s because our times were going up by 1. Here we started our times going up by 2, and our temperatures went up by 16. It went up 2 times 8 degrees. So this would be 92 degrees at 9 minutes. Well, that's not enough. We want 100 degrees. So I'll try 10 minutes. And then we take 9 minutes, add another 8 degrees, and we do get 100 degrees Celsius. Okay, so we use the patterns. We guessed 9 minutes. That wasn't enough, so we checked our result, guessed another one, and we found the value exactly. Okay, so let's make sure we answer the question. It takes 10 minutes for the water to come to a boil. And that completes this unit, so make sure you do all of the U-Try problems and check your answers. The answers are in Math AS, and your next step after that is to work on the Math AS homework assignment. See you at the next unit.